Tonight, we're heading to the place the internet loves more than almost any other blank space on the map, a place that has been accused of hiding just about everything: Antarctica. If you've ever fallen down a late-night rabbit hole, you've probably seen it cast as the ultimate cosmic storage closet. People put everything there: lost cities from before the last ice age, Nazi strongholds that somehow survived the war, crashed alien craft, entrances to the hollow earth, and for a while, even evidence of a parallel universe where time runs backwards. It's like the world's coldest junk drawer of weird ideas. And right in the middle of all of that, there is one very real, very stubborn little puzzle. A strange radio signal that scientists genuinely can't explain yet. That signal was picked up by an experiment called ANITA, the Antarctic Impulsive Transient Antenna. Picture a giant helium balloon drifting lazily over an endless sheet of ice, carrying a ring of sensitive radio antennas like a floating crown. Those antennas are listening for ghost-like particles called neutrinos, tiny, almost massless things that normally pass straight through the Earth as if the planet were made of fog. Every so often, a particularly high-energy one slams into the Antarctic ice, creates a shower of secondary particles, and lets out a tiny puff of radio waves. Anita's job is to catch those puffs and, from them, reconstruct some of the most extreme cosmic events in the universe. Simple enough in theory. Except that on a few occasions, Anita picked up signals that looked very much like those neutrino-style puffs, but coming from the wrong direction, as if something had blasted up from deep under the Antarctic ice, traveled through thousands of kilometers of rock, and popped out into the atmosphere to say hello. According to the physics we use on weekdays, that really shouldn't be happening. Imagine setting up speakers on your roof to listen for rain, and instead hearing the sound of heavy droplets hitting from underneath your floorboards. When those results got published, the conspiracy world did what it does best. Overnight, this niche little anomaly was dressed up as proof of hidden bases under the ice, alien transmitters, secret government experiments, or a doorway to another universe politely knocking from below. Tonight, we're going to take the fun route. We're going to enjoy the myths, the conspiracies, the legends, and then calmly walk them past the slightly grumpy bouncer that is actual data. We'll spend time in the frozen world where real scientists work, where neutrinos glide through ice, where balloons drift over a continent that used to be drawn on old maps as Terra Australis Incognita, the unknown southern land. We'll talk about what Anita actually saw, how hard researchers tried to blame it on something boring, and why the phrase new physics keeps hovering just out of reach like a rumor no one wants to repeat too loudly in case they're wrong. Before we head down to the ice, go ahead and get comfortable. If you can, dim the lights a little, let your shoulders relax, maybe put on some soft background noise. This is not a test of your memory or a quiz on particle physics. This is a long, gentle story you're allowed to fall asleep to. If you enjoy drifting off to deep dives into strange corners of history and science, with a little side dish of conspiracy theories gently defanged, it really helps if you tap like on this video and subscribe to never miss another quiet voyage through the mysterious corners of our world, all crafted to ease your mind into rest. And because I always like to know who I'm sharing the night with, let me know in the comments where you're tuning in from and what time it is for you. Are you listening at midnight in a big city, in the early morning in a quiet town, or somewhere in that timeless zone where you've lost track a little? With that, let's head to the bottom of the world, where the ice is thick, the legends are even thicker, and a tiny puzzling signal has given everyone one more Antarctica mystery to argue about. Chapter 1: Life at the End of the World. The first thing to understand about Antarctica is that it doesn't care about you at all. It's not hostile, it's just indifferent. It is the most brutally honest place on Earth, a continent that simply is, and you either adapt or you don't. Most don't. Imagine standing on the edge of a world that feels barely connected to the one you know. The sky is enormous, almost too big. The air hits you like you've opened the freezer door of the universe. Every direction is white. White ice, white horizon, white silence, and underneath that silence lies a thickness of ice so deep and ancient it feels like standing on fossilized time. For much of human history, Antarctica wasn't even a real place so much as an idea. Ancient mapmakers drew a giant southern landmass because they thought the world needed balance, as if the continents were part of some cosmic feng shui arrangement. Philosophers imagined a symmetrical Earth, so naturally there had to be an enormous southern continent mirroring the north. No one had actually seen it. They simply assumed it existed, a continent of pure speculation. When explorers finally arrived centuries later, they discovered something far stranger. Not a lush counterpart to the north, but an entire world ruled by ice, wind, and silence, a place where nothing grows except frostbite. Early expeditions learned this the hard way. Their journals read like slow, poetic horror stories. Snow without end, a steady wind that cuts like a saw, no sound, no smell, no life. They wrote about the isolation too, the kind that doesn't just surround you but seeps into you. There's a reason so many Antarctic researchers describe a subtle psychological shift after spending long months there. The continent changes your sense of scale. It makes you feel small in a way that's strangely peaceful and deeply unsettling at the same time. But Antarctica's indifference isn't just atmospheric, it's physical. Everything about it is unfriendly to human bodies. The cold isn't just cold, it's a force. Antarctica can freeze exposed skin in minutes. It can hide crevasses under snow so perfectly flat they look solid enough to walk on, until you're falling 30 meters into a blue ice cavern. The wind can knock you over like a bored giant flicking a pebble. This isn't a continent where humans built cities or carved history into stone. It's a place where the world hides its age. Beneath the ice lies mountain ranges older than humanity, lakes sealed off for millions of years, and rivers, yes, rivers, flowing beneath the frozen surface in total darkness, untouched by sunlight since long before our species existed. It's not hard to understand why Antarctica became a magnet for myth. When a place is this empty, this silent, this uncooperative, people will fill it with stories. And it doesn't help that the continent is genuinely weird in ways that aren't mythical at all. The South Pole stations run on schedules detached from sunlight because the sun only rises and sets once per year. The air is so dry and cold that sound behaves strangely. You can hear things from far away one moment and hear nothing at all the next. Ice cores pulled from the continent act like time machines, holding bubbles of air older than civilization. Even the magnetic field behaves slightly differently here, giving navigational instruments a subtle but eerie misbehavior. For centuries, sailors recorded strange compass swings near the southern seas, convincing them something unnatural lived down there. And then there's the isolation. If your equipment breaks, you fix it or you freeze. If someone gets hurt, rescue is measured in days or weeks, not minutes. People who work here describe it as living on another planet. but one without astronauts, mission control, or backups. This is the setting for our mystery, a world that refuses easy answers, a continent built for secrets, because beneath that vast, crushing ice sheet lies more unknowns than any place on Earth. Rock we've never touched, caverns we've never seen, mountains mapped only by radar shadows, hidden lakes that may contain organisms untouched by modern evolution. And it's from this place, from deep below this ancient, silent world, that a strange signal once rose upward, caught by a balloon floating far above the ice. But before we get to that signal, we have to understand the human relationship with Antarctica a little more. It's a place that scientists visit with reverence, adventurers visit with fear, and conspiracy theorists visit with enthusiasm. Everyone sees what they want to see. Some see an untouched laboratory for the universe. Some see the remnants of forgotten civilizations. Some see alien bases, lost cities, or doorways to inner realms. And some, especially the scientists, see a place where physics itself becomes crisp and clean, easier to observe because the world is stripped down to ice and sky. Antarctica is a blank page where we project our imagination. It is also a hard truth, unshaped, unyielding, indifferent. And it is the last place on Earth anyone expected to hear a radio pulse rising from below. A pulse that should not exist under any model of physics we currently have. We'll get to that soon. But first, let's step a little deeper into the history and character of this strange continent. So when that signal finally rises, you'll feel the full weight of what it means. If you ever find yourself living in Antarctica, and I mean really living there, not just stepping off a cruise ship for a selfie with a penguin, you quickly learn that the continent has its own rhythm, not a human rhythm, a slow, ancient rhythm that you have to match if you want to stay sane. The first thing you learn is that Antarctica gives you no sensory variety. The colors are minimal, the sounds are minimal, even the smells are minimal. It's a place where your brain is left with nothing but itself, and that's not always a comforting experience. Researchers often compare long Antarctic seasons to living inside a blank sheet of paper. At McMurdo Station, the largest human settlement on the continent, you wake up to a landscape that looks exactly like it did yesterday and the day before, and likely how it looked the day you arrived. That sameness does something to people. Not in a dramatic losing your mind way, but in a quiet, slow recalibration where time becomes a little blurry and your internal clock starts drifting like the ice shelves. Most days are built around simple survival rituals, layering clothes, checking equipment, eating food that is much better than it has any right to be, and talking about the weather because the weather is the only thing that ever really changes. And even then, it doesn't really change. It just changes intensity. On good days, you get a cold breeze. On bad days, the wind becomes a personality, loud, insistent, almost conversational. Researchers joke that Antarctic wind feels like it's trying to borrow your jacket and your face, and maybe your entire skeleton. Even walking outside becomes a full-body negotiation. The air is so dry it crackles in your throat. Your eyelashes freeze into tiny, inconvenient stalactites. Your breath condenses into a cloud that instantly crystallizes and drifts away like you're exhaling tiny galaxies. But despite all that, there's a strange comfort to the routine. Antarctica strips life down to its essentials. Wake up, layer up, walk carefully, work carefully, eat something warm, drink something warmer, sleep, repeat. There's something soothing about that predictability, something almost meditative. Of course, not everything is peaceful. Antarctic storms are cinematic in the worst possible way. Visibility drops from miles to inches. The wind screams like it's furious at the existence of air. Snow slaps your face sideways, and the ground becomes indistinguishable from the sky, a condition known appropriately as whiteout, where the horizon simply disappears and you cannot tell what direction is up. Veteran researchers carry ropes between buildings during storm season so no one gets lost walking from one doorway to another. It sounds dramatic until you realize that losing sight of a building 20 feet away is normal here. The cold drives people indoors, and indoors is where the psychological challenge begins, because when you put 50 highly trained scientists into a small metal station isolated from the world, strange little social ecosystems start forming. There's always the one guy who gets overly attached to the coffee machine. There's always someone who becomes unreasonably passionate about the foosball table. There's always a quiet, unspoken competition to see who can produce the most gourmet meal from frozen supplies. And there's always, without fail, that one researcher who suddenly grows a beard and insists on being called Icebeard or Frost Lord or something equally concerning. But for all the jokes, winter over crews form a family-like bond. They depend on one another in a very literal way. If your colleague forgets to check a generator, you might freeze. If someone misplaces a radio, you could lose contact. If someone makes a minor mistake fixing an outside sensor, they could get stranded in the cold. There is no such thing as someone else will handle it here. Everyone handles it. Together. Antarctica has a way of shrinking the world. It turns scientists into roommates, roommates into teammates, and teammates into reluctant, sleep-deprived philosophers, especially during the long winter nights when the sun doesn't rise for months. The darkness affects people differently. Some find it peaceful, others find it unsettling, like the world is stuck in a cosmic pause menu, and a few find it strange enough to spark the imagination. That's where the myths start to creep in. Not because anyone believes them, but because Antarctica feels like the kind of place where myths should be true. When you're walking across a frozen plain with no sound but your own breathing, it's easy to imagine that something ancient might be sleeping below your feet. When the wind whips across the ice and makes the metal siding of a research hut hum, it can sound eerily like distant machinery. And when you work near the South Pole, surrounded by deep ice and long shadows, a strange pulse rising from beneath the ground doesn't feel impossible, it feels inevitable. Researchers don't admit it, but they feel the Antarctica effect. The place makes the mind wander. It makes the imagination stretch. It makes the world feel thinner. And this is why, when the first Anita signal was detected, an upward-moving radio pulse that made no scientific sense, people didn't just ask, "What is that?" They asked, "What on earth is happening under the ice?" Because in a place where your senses are muted and your mind is loud, sometimes the boundaries between science and story blur a little. Antarctica does that to you, and as we move closer to the mystery itself, it's important to remember. This is a continent built for secrets. It hides things well. It hides things completely. And every once in a while, maybe, it lets something slip, like a whisper rising from the deep. For as empty as Antarctica appears on the surface, the real story lies beneath. Most of the continent is covered by an ice sheet so thick it could swallow skyscrapers whole. And beneath that, hidden under 3 miles of frozen silence, is a world we barely understand. Antarctica is like a book where the first few pages are glued shut. We can see the cover, we can read the title, but most of the story remains sealed under layers of ancient ice, and the few chapters we have managed to peek at are strange enough to keep even the most rational scientists up at night. Let's start with the ice itself, Because this ice isn't just frozen water, it's time. Each layer is a page, snowfall compacted over thousands, tens of thousands, even hundreds of thousands of years. And when scientists drill core samples, they're not just pulling up frozen cylinders, they're pulling up history. Inside those cores are air bubbles from ancient atmospheres, volcanic ash from eruptions that happened long before humans farmed anything, dust from deserts that no longer exist, chemical traces of climate shifts and cosmic events. It's humbling to hold a piece of air from 100,000 years ago and realize you are breathing the identical molecules someone once inhaled near a Neanderthal campfire. But the ice does more than preserve history. It hides geography. Antarctica is not flat under all that whiteness. Radar scans reveal mountain ranges taller than the Alps, valleys deeper than the Grand Canyon, and entire basins the size of countries. None of it visible to the naked eye. All of it sealed away by nature's thickest security system. One of these hidden landscapes is the Gomburtsev Mountains, a full-sized mountain range buried under ice like a geological time capsule. No one has ever seen its peaks. No one has touched its rock. Yet the range sits there, vast and silent, keeping whatever stories it holds to itself. And then there are the lakes, more than 400 subglacial lakes, some sealed off for millions of years. The most famous, Lake Vostok, is a dark, pressurized body of water buried under 2.5 miles of ice. It's been isolated since long before humans evolved. When Russian scientists drilled into it, the scientific world held its breath, not because anyone expected monsters, but because the idea of a lake sealed for millions of years feels like something out of mythology. These are environments where life, if it exists, would be alien, not in the extraterrestrial sense, but in the evolutionary sense. Microbes shaped by ancient conditions, surviving in complete darkness, isolated since the age of giant mammals, life that has absolutely no idea humans exist. And that's just the biological mystery. The physical mystery runs even deeper. Antarctica has voids, massive empty chambers inside the ice, caverns warmed by geothermal heat, places where the ice melts from below and forms vast, echoing hollows. One such system beneath the Ross ice shelf is so large that researchers described it as cathedral-like. Others compare the acoustics to underground train tunnels. It's very easy to see how stories of structures under the ice began. When your radar shows long, rectangular echoes or oddly aligned caverns, your mind does what minds do. It looks for patterns, for meaning, for architecture. Even NASA's mapping satellites occasionally pick up strange symmetrical anomalies below the surface. Perfect lines, perfect angles, almost certainly geological, but perfectly capable of inspiring winter-over crews to mutter, well, what if it's not? And there's another reason Antarctica inspires so much speculation. Its map is still incomplete. Yes, in 2025, the most technologically advanced era of human history, we still have blurry, low-resolution knowledge of what exists beneath the ice. There are areas we've never scanned, areas where radar doesn't penetrate cleanly, areas where shifting ice creates phantom signals, echoes of something that might be rock, might be water, or might be, well, something else. And while science gives us the most logical explanations, the mind is rarely satisfied with logic alone, especially in a place this empty and this old. "No one knows what's under there" is a phrase that sticks to the imagination like frost. Add to that the fact that Antarctica has been warm in the past, not just warm, but forested. There was a time when this frozen land was lush and green, full of rivers and moss and insect life, even trees. a time when dinosaurs walked across ground that is now buried under 2 miles of ice. That contrast alone is enough to create a sense of dissonance, as if the continent is a palimpsest, a layered record of forgotten worlds. The idea that the ice could be hiding the remnants of something ancient, fossils, landscapes, or maybe just mysteries we don't have names for, isn't far-fetched, not in a scientific sense. Antarctica changes slowly but dramatically, and it has erased entire ecosystems before, entire histories, entire environments. So when a team of scientists launches an experiment like Anita, a balloon drifting high above this ancient ice-covered world, it's not surprising the continent might whisper something back. Not surprising that an anomaly rising from below would ignite imaginations around the globe. Because Antarctica is full of strange shapes, strange sounds, strange gaps, strange echoes, and for all the ground-penetrating radar and satellite scans and seismic readings, the continent is still the closest thing Earth has to a blank chapter. And what better place for a mystery signal to appear than a chapter that no one has read? We're almost at the moment when Anita detects its strange pulse, its upward moving signal that defies explanation. But before that, we need one more piece of context: the people who study this continent, and how even they sometimes struggle to explain the things it does. We'll pick that up in the next segment. For all its emptiness, Antarctica attracts a very specific kind of person, the kind who willingly signs up to work on a continent that looks like the loading screen for a survival game. These are geologists, glaciologists, atmospheric scientists, astrophysicists, seismologists, people whose job descriptions often boil down to look at ice, think about ice, occasionally fall into ice. They're brilliant, they're patient, they're mildly eccentric in a charming, sleep-deprived kind of way. And most importantly, they are the first to admit that Antarctica still surprises them. Spend enough time around Antarctic researchers and you start hearing small confessions. Not dramatic, not mystical, just the occasional shrug followed by, "Yeah, we don't totally understand that yet." Like the way crevasses form in perfectly straight lines for no obvious reason. Or how ice sometimes echoes with booming sounds that resemble distant thunder even though there's no storm, no clouds, no atmospheric reason at all. Or why certain radar scans show odd shadows, long rectangular voids that vanish when measured again a year later. No one thinks these are aliens or hidden bunkers or ancient machinery, but the unexplained is part of daily life here. There's even a running joke among field scientists. If it happens anywhere else, it's weird. If it happens in Antarctica, it's Tuesday. And that attitude makes sense because the continent runs on extremes. Extreme temperature, extreme isolation, extreme pressure, extreme dryness, extreme geography. Everything here is pushed to its limits. Equipment breaks faster, batteries drain faster, people tire faster, metal snaps in the cold. Ice shifts under your feet, even when the world around you looks frozen solid. So yes, Antarctica produces weirdness, not supernatural weirdness, not conspiracy weirdness, just natural, quiet, frustrating weirdness that comes from studying a place older than your entire species. Researchers often describe a sensation they call Antarctic awareness. After a few weeks on the ice, you start picking up patterns, subtle things you never noticed before. The temperature dropping by 1 degree can change the sound of your boots against the ice. The direction of the wind can tell you how the sky will look 5 hours from now. The way the ice surface reflects light can hint at hidden crevasses in places that look perfectly safe. It's not magic, it's experience, but it does feel a little magical when you're there long enough. And then there are the stories, the unofficial ones, the ones shared over dinner in the galley, or whispered during whiteout nights when the wind rattles the station walls. Stories like the scientist who heard rhythmic tapping beneath the ice during a midnight equipment check, the team whose GPS malfunctioned so badly they swore the ground shifted under them, the seismic instruments that picked up unexplained vibrations near buried lakes, the expedition that found an echo chamber under the ice so perfectly shaped it sounded engineered. Again, no one jumps to supernatural conclusions, but they do admit that Antarctica has its moments, moments where the world feels thinner, and the line between the known and the unknown blurs just a little. And that's part of the reason Anita's strange signal hit so hard. Not because anyone thought it was a message or a machine or a civilization, but because it came from this place, a continent already full of quiet oddities. If the same signal had appeared in Kansas, the world would have shrugged. If it appeared over Paris, someone would have blamed a microwave. If it appeared over New York, it would have been dismissed as interference from a passing jet. But in Antarctica, a place where nature routinely outweirds fiction, that's different. Scientists here live with a sense of constant humility. They understand that the planet's deepest mysteries often show up in the places we study the least, and Antarctica is studied less than any continent on Earth, not for lack of desire, but for lack of access. There are no cities, no roads, no infrastructure, no easy routes. If you want to know what's under the ice, you either drill through kilometers of frozen time or bounce radar signals off bedrock and hope the echoes come back clean. In other words, Antarctica doesn't reveal its secrets. It teases them, which is why, when a radio pulse suddenly rose from beneath the continent, clean, crisp, and precisely timed, scientists didn't just write it off. They leaned in. Because even though researchers joke about weirdness, they're not reckless. They're cautious, careful people. When something truly unusual happens, they notice. They take it seriously. They analyze it, test it, question it, and then question their questions. That's exactly what happened with Anita. But before we get to the moment the signal appeared, we need to finish understanding the foundation of this place. Not the science, but the feeling. Because Antarctica has a presence. It doesn't just exist. It watches. Not literally, of course, but spend a winter here and you start feeling like the continent is paying attention. Not in a threatening way, just in a patient, ancient, slow way, like a mountain observing an ant. And when something rises from beneath its ice, even scientists feel something shift inside them. A small tightening in the chest, a spark of curiosity, a whisper of, okay, that's new. In the next segment, we'll finally approach the moment everything changed, the day Anita detected an upward moving signal that normal physics cannot explain. By now, you can picture Antarctica the way the researchers do, not just as a geographical location, but as a mood, a presence, a slow, humming backdrop where the world feels older, quieter, and a little stranger than it does anywhere else. That atmosphere is important because it shapes the way the Anita anomaly landed. Not just scientifically, but emotionally. If this signal had appeared anywhere else on Earth, it would have been an interesting puzzle. In Antarctica, it became a mystery, and before we get to the moment the signal rose, it helps to understand the calm that came right before it. the strange, serene normalcy that makes what happened next feel even more out of place. Imagine a day in Antarctica so plain it almost erases itself. A windless day, the kind you only get a few times per season, when the air stands perfectly still and the world feels paused. The sky is a pale, washed-out blue, flat and colorless. The horizon blends into the ice in a way that makes distances impossible to judge. If someone stood a mile away, you'd see them with perfect clarity, but you'd have no idea if they were 100 feet tall or child-sized. That's what Antarctica does. It removes depth. It removes scale. Everything looks like a painting. Scientists love these days because the equipment behaves better. Instruments don't get battered by wind. Signals don't scatter as much. Radios behave. And people, for once, can walk from building to building without feeling like they're being sandblasted by the planet. These calm days usually feel peaceful, almost sacred. They give researchers a moment to relax and appreciate where they are. But they also sharpen the senses. When the world is quiet, little things stand out. A distant crack, a faint echo, a strange vibration under the ice. Antarctica is a place where silence itself becomes suspicious. On days like this, researchers check gear, analyze samples, recalibrate instruments, and take long contemplative walks, their boots crunching softly across snow that hasn't been touched by human feet in months. You can hear your own heartbeat. You can hear your breath. You can hear the ice groaning gently beneath you as layers shift and settle. It's a peaceful sound if you don't think too hard about the fact that you're walking on top of a continent-sized frozen ocean. And far above all of this, floating at the edge of space, is Anita. Anita isn't a satellite or a tower or a ground station. It's a balloon the size of an office building, lofted high into the stratosphere where the air is thin and the world below looks like a cracked sheet of white porcelain. Suspended beneath that balloon is a ring-shaped array of antennas pointed downward, listening for radio bursts bouncing through the ice. It doesn't look dramatic. It looks like a strange science fair project drifting lazily over the most hostile place on Earth. But despite its simplicity, Anita is one of the most sensitive neutrino detectors ever built, capable of catching the faintest radio pulse from particles that barely interact with reality at all. On that calm day, Anita's instruments were behaving perfectly. No interference, no storms, no unexpected noise. Just clean, crisp data flowing back to the researchers monitoring the mission. They weren't expecting anything unusual. Most experiments don't detect history-making events. Most collect months of silence punctuated by the occasional spark of something interesting. Anita had already completed missions before, successful ones, but nothing groundbreaking. Nothing paradigm-shaking, nothing that would put Antarctica on the front page of physics journals. But below Anita, deep under the ice, something happened, something small, something fast, something that didn't match anything scientists expected. A particle, if that's what it was, moved upward through the Earth, not sideways, not down from space, but up, through thousands of kilometers of solid rock and mantle and crust, something that standard physics says should be impossible. Anita caught the radio pulse it left behind, clean, precise, unmistakable, and everything changed. Researchers didn't know it yet, not in that moment. They only saw a spike, a tiny anomaly, a blip in an ocean of data. But eventually, when they traced the signal, analyzed the geometry, checked the polarization, and reconstructed the path, they realized something extremely strange. The pulse wasn't coming from above, it was coming from below, a signal rising from beneath Antarctica, a signal that shouldn't exist, a signal that would become the center of one of the most persistent scientific mysteries of the 21st century. Chapter 1 ends here, with the quiet before the anomaly. In the next chapter, we'll dive into the moment scientists realized something impossible had just tapped on the bottom of the world. Chapter 2. The signal scientists can't explain. When Anita's first strange pulse arrived, it did not announce itself with drama. There were no flashing alarms, no frantic radio calls, no cinematic warnings about energy readings off the charts. It slipped into the data quietly, almost politely, like someone tapping very gently on a window to see if anyone is awake. In fact, the researchers monitoring Anita didn't even notice it right away. Most of the time, Anita's logs are a flood of ordinary radio noise, cosmic rays, static from the atmosphere, reflections bouncing off ice layers. 99% of what Anita hears is the scientific equivalent of background chatter. But when they looked back through that day's data later, something stood out. A single, sharp, clean pulse. Perfectly shaped, perfectly timed, and pointing in the wrong direction. If you imagine radio data as waves scribbled across a graph, this one looked like someone had carved a neat tick mark into the noise, intentional, specific, impossible to confuse with anything else. The first thing the researchers did was check for a reflection. That's the obvious explanation. Radio pulses can bounce off awkwardly angled surfaces, ice cliffs, buried ridges, layers of compressed snow. Antarctica is great at impersonating geometry it doesn't actually have, but reflections leave fingerprints. They flip certain parts of the signal, they distort angles, they smear out timing. This pulse didn't do any of that. The polarization was perfect, the path was direct, and the angle, that was the truly unsettling part. The signal arrived as if it had traveled upward, from deep beneath the earth, straight through the Antarctic ice sheet, emerging into the open air where Anita could hear it. That's not how nature works, not at these energies, not for this kind of signal. Under normal physics, a particle capable of producing that pulse would have been stopped, absorbed, dissolved, or scattered long before reaching Anita's antennas. It would be like a bullet passing unharmed through a mountain, a forest, a building, and then gently tapping a bell on the other side. It shouldn't happen. It couldn't happen. And yet there it was. The team followed protocol. They didn't panic. They didn't jump to conclusions. They didn't whisper about conspiracies or anomalies or anything remotely dramatic. They simply flagged it, filed it, and began running tests to make sure Anita wasn't misbehaving. It wasn't. The signal behaved so cleanly that the team did something scientists rarely do with weird data. They said, "Okay, let's not delete this one." Weeks passed. The analysis got deeper. Models were checked, angles recalculated, paths reconstructed. The anomaly held steady. No matter which way the data was sliced, the result was the same. A particle shower had moved in the wrong direction. But as odd as it was, one anomaly isn't enough to rewrite physics. Single events can be flukes, statistical hiccups, rare coincidences, the universe's tiny jokes. So the team moved on, made notes, and prepared for the next ANITA mission. Years later, Anita flew again, drifting high above the ice like a giant mechanical jellyfish against the pale sky. For the most part, the flight was routine. Clean weather, cooperative winds, solid data. And then it happened. A second pulse, nearly identical to the first. Same shape, same angle, same impossible trajectory. A twin of the anomaly no one could explain. Now things were different. One anomaly is a curiosity. Two anomalies, that's the beginning of a pattern. This time the researchers dug deeper. They overhauled the event reconstruction. They compared both signals side by side. They cross-referenced timing, frequency, and path through Earth's interior. Everything matched with eerie precision. And once again, the signal rose from below. The scientific community split into two predictable groups right away. Group 1. This is probably a rare standard model event. Weird, but not world-breaking. Group 2. Okay, we are officially outside the standard model's comfort zone. Group 1 was being responsible. Group 2 was being honest. Because if these pulses were what they appeared to be, upward moving cosmic particles, then something truly strange was happening. Either a known particle was behaving in an unknown way, or an unknown particle had made its presence known. Both options are unsettling. Both options are exciting. Both options are scientifically enormous. And that's when Ice Cube entered the conversation, not as a challenger, but as a witness. But before we get to Ice Cube, let's take a moment to appreciate where we are in the story. Two clean signals, two upward paths, zero satisfying explanations. A mystery that began quietly was now pulling the world into its orbit. Let's explore how scientists first tried to make sense of these signals, and what they discovered when they compared Anita's impossible readings with Ice Cube's deep ice observations. After Anita's second impossible signal appeared, the scientific world did what it always does with unsettling data. It politely handed the problem to someone with bigger equipment. Enter Ice Cube. If Anita is a drifting ear in the sky, Ice Cube is the opposite. A giant, light-sensitive observatory drilled straight into Antarctica's frozen heart. Most people imagine a big metal tower or a building full of blinking lights. Ice Cube is nothing like that. It's a detector made of ice, literally ice, stretching more than a mile down into the continent. 5,160 sensors sit buried in the darkness, spaced along long strings that run through ancient, perfectly clear ice. This clarity matters, because when a high-energy neutrino interacts with that ice, it emits a faint blue flash, Cherenkov light, like a cosmic firefly. Ice Cube sees those tiny flashes and reconstructs what passed through the Earth. It is one of the only instruments on the planet that can check whether Anita's upward-moving signals were the beginning or end of something stranger. So naturally, when those anomalous pulses appeared, every researcher asked the same question. Did Ice Cube see anything like this? And Ice Cube answered in the most frustrating way possible. Sort of. Not a match, not a contradiction. Not nothing, just weirdness, hints, echoes, exactly the kind of response that makes scientists lean closer instead of stepping back. Ice Cube's first surprise: odd angles. Ultra-high energy neutrinos rarely travel upward through Earth. At those energies, the Earth becomes too dense, too thick for them to pass through without interacting. It's like asking a raindrop to pass straight through a brick wall. And yet Ice Cube's archive contained events that arrived from suspiciously steep angles, almost as if they were nudging up from below. Not as dramatic as Anita's signals, but unmistakably strange. Ice Cube flagged a few key events, some with energies so high they strained standard model predictions, some with trajectories too steep to make sense, some that seemed to cluster faintly toward similar regions of the sky. Individually, they could be written off. Together, they formed a pattern, the same kind of pattern you get when two different people hear different parts of the same faint noise. the 3 Anita-compatible events. Eventually, Ice Cube researchers narrowed their search down to 3 unusually energetic events that could, depending on assumptions, fit with Anita's anomalies. These weren't perfect matches, but they had trajectories that challenged Earth's opacity, energies consistent with the kind of particle ANITA might detect, timing that didn't contradict Anita's missions, a whisper answering a whisper. This was the moment where the tone in physics departments shifted from "is ANITA broken?" to "okay, what exactly are we looking at?" Because Anita catching 1 impossible signal is interesting, Anita catching 2 is compelling, Ice Cube having related weirdness in its archives. That's when curiosity becomes unavoidable. Standard explanations start to stretch. Physicists aren't quick to jump into new theories, and the first attempts to explain all this were aggressively grounded, misreconstructed events, rare neutrino interactions, atmospheric reflections, ice layer complexities, noise sources disguised as signals. Every normal explanation was tested, most failed. A few could almost explain the data, but they required a rare event happening twice, under extremely specific conditions, at extremely high energies, with strange alignments and identical-looking waveforms. Nature usually doesn't do copy-paste anomalies, and as more eyes looked at the data, the standard model explanations began to look less like solutions and more like creative excuses. It became clear that if these 2 detectors were seeing echoes of the same phenomenon, then something genuinely unusual was happening. Not supernatural, not conspiratorial, just scientifically inconvenient. The Ice Cube - Anita tension. The tension boiled down to this: if Anita saw a tau neutrino bursting upward from deep Earth, Ice Cube should have seen a partner event or a precursor. Ice Cube didn't, so scientists offered 2 options. Option A: Anita detected something that wasn't a tau neutrino. Option B: Anita and Ice Cube saw 2 sides of a new phenomenon. Both options point toward physics operating in a regime we don't fully understand. Quietly, cautiously, the phrase "new physics" began to appear in papers, not boldly, not loudly, but carefully, like someone testing a floorboard before stepping down on it. That's how science responds to anomalies, not with excitement, but with an uncomfortable, slow-building acceptance that something strange might be real. The puzzle becomes a problem. By now, the situation looked like this. Anita detected 2 upward-moving signals. Standard physics could not explain them cleanly. Ice Cube's archive contained suspiciously similar high-energy events. No one could dismiss the anomaly. No one could confirm it either. It was no longer a glitch. It was no longer an outlier. It was a problem, an elegant one, but a problem nonetheless. And that's the moment theorists started rolling up their sleeves. Because if the traditional explanations don't work, you start testing the ones that sit just outside the map. When a mystery like Anita's upward-moving pulses appears, scientists don't start with wild theories. They start with the boring stuff, the responsible stuff, the "please let this be an equipment glitch so I can go home and eat something warm" stuff. In other words, they try to disprove the anomaly before even considering the possibility that it might be real. So the first round of explanations fell into one simple category. This is normal. You just don't understand why yet. Let's walk through the early suspects. 1. Suspect 1. Reflection errors. The most comforting possibility was that the signal wasn't upward moving at all. It only looked upward because it bounced off something weird. This happens all the time with radio waves. Antarctica's ice layers aren't flat. They're stacked like a crooked wedding cake, with layers bending under mountains, flowing into valleys, and forming pockets of strangely angled surfaces. If Anita caught a downward moving particle that reflected off an upward angled ice shelf, it might appear inverted. A simple, accidental trick of geometry. The problem? Reflections flip the polarity of radio signals. Anita's pulses did not flip. They preserved the exact orientation expected only from a direct upward moving shower. Strike 1, 2. Suspect 2. Instrument glitches. Whenever an experiment produces something unexpected, the first instinct is to blame the experiment itself. Maybe Anita hiccuped, maybe a cable jiggled, maybe thermal noise produced a false pulse. But Anita is basically a giant floating antenna farm designed to minimize that exact problem. The team checked everything: timing systems, trigger algorithms, sensor calibration, orientation logs, power fluctuations, thermal variances, sun interference, Earth limb reflection models. Nothing misbehaved. The instruments were steady as a heartbeat. The pulse was not a glitch. Strike 2. 3. Suspect 3 cosmic rays doing something weird. Ultra-high energy cosmic rays slam into our atmosphere constantly, producing cascades of particles that Anita hears all the time. Some of those cascades scatter, split, reflect, or refract. The idea was simple. Maybe a cosmic ray bounced in a strange way that mimicked an upward signal. But cosmic rays don't come from beneath the Earth, and even if they could reflect upward, the signal shape would be stretched or distorted. Anita's events were crisp, clean, too clean. Strike 3. 4. Suspect 4. Tau neutrinos taking a miracle path. This was the first explanation that felt possible, if still improbable. Tau neutrinos, the heaviest of the 3 neutrino flavors, can pass through Earth, interact near the surface, and burst upward as tau particles that decay into particle showers. This process can produce the exact type of signal Anita detected. But here's the issue. At the energies Anita observed, the Earth is basically a brick wall. A tau neutrino would not make it through thousands of kilometers of rock. The standard model predicts the chance of this happening is so small it might as well be zero, the kind of zero that scientists call practically impossible unless the universe is playing a joke. But Anita didn't see one of these impossible upward events. It saw 2. The odds of that happening are so tiny that calculators start sweating. So while tau neutrinos were the only standard model explanation that technically worked, the math was ugly. It was like saying, sure, lightning could strike you twice, but maybe check the sky for aliens first. 5. Suspect 5. Human error, the most beloved suspect. Every scientific anomaly eventually reaches the stage where everyone asks the same tired question. Did someone just label the data wrong? The team triple-checked, quadruple-checked, quintuple-checked. They even reanalyzed the waveforms using outside groups to avoid bias. The verdict was unanimous. No errors, no mislabeling, no midnight coding mishaps. Anita had genuinely recorded 2 upward-moving radio pulses. 6. The moment the normal explanations ran out. Scientists don't like running out of normal explanations. It's uncomfortable. It means you have to step off the map. But that's exactly where Anita led them. Once every reasonable explanation failed, researchers were forced to move to the next stage of scientific mystery solving. Okay, if it's not normal, what else could it be? And that's when the theorists came in, cheerfully, enthusiastically, carrying chalk and coffee and equations that look like spells. They proposed ideas ranging from mildly strange to cosmically absurd supersymmetric particles, sterile neutrinos, dark matter decay, Lorentz violating physics, unexplained Earth emergent particles, or even unknown forces interacting with ice in ways we've never imagined. None of these were claims, just possibilities, mathematically grounded, physically plausible at high energies, and most importantly, impossible to dismiss outright. For the first time, Anita's anomaly wasn't just a curiosity, it was a doorway, a small one, yes, but real. A doorway into physics we haven't mapped yet. In the next segment, we'll walk through the boldest scientific theories, the ones that stretch the edges of reality just enough to make sense of Anita without drifting into science fiction. Once the standard explanations wore thin, scientists finally permitted themselves a rare indulgence, stepping into the realm of ideas that sit just outside the edge of known physics. Not fantasies, not sci-fi, just the respectable kind of strange. The theories that live in academic hallways, waiting patiently for data bold enough to invite them in. Anita's anomaly was that invitation. So theorists began proposing models that wouldn't break the laws of physics, but might bend them gently. Models that could slip through the cracks of what we think we understand. Let's walk through the most compelling ones. 1. Supersymmetric Staus, the heavy ghost particles. Supersymmetry is a theoretical extension of the standard model that says every known particle has a heavier partner: electrons, selectrons, quarks, squarks, tau leptons to Staus. A Stau is a hypothetical, heavy, long-lived particle. And the beauty of the Stau hypothesis is that it solves Anita's geometry problem elegantly. A high-energy cosmic neutrino enters the Earth. It interacts and produces a Stau. The Stau travels long distances through rock, much further than normal particles. Near the surface, it decays into a tau. The tau produces the upward particle shower Anita detected. It's neat. It's tidy. It requires 0 conspiracies, 0 aliens, 0 portals, just a new particle we haven't catalogued yet. The only issue? The Large Hadron Collider hasn't found Staus, but that doesn't rule them out. It just means that if Staus exist, they're rarer or stranger than expected. 2. Sterile neutrinos. The ghost behind the ghost. Neutrinos already barely interact with reality. They pass through planets, stars, and galaxies like they're made of smoke. Sterile neutrinos are even more elusive, hypothetical particles that interact only via gravity. They'd travel through Earth like it wasn't there at all. If sterile neutrinos exist, one could pass through Earth untouched, transform, oscillate, into a normal neutrino near the surface, then produce a tau shower detected by ANITA. No broken physics, no magical shortcuts, just a new type of neutrino doing something neutrinos already do, changing flavors. If Anita saw a sterile neutrino oscillation, it would be one of the biggest discoveries in modern physics. 3. Dark matter decay. The universe whispers through ice. Dark matter makes up the majority of matter in the universe. We've never detected it directly, but we know it's there from gravity. Some theories say ultra-heavy dark matter particles occasionally decay, producing high-energy debris, exotic particles, neutrino-like bursts. upward moving showers. If a dark matter particle decayed inside Earth, even deep in the mantle, the resulting particle could burst upward and produce Anita's signal. This one is especially elegant because it explains the energy, it explains the direction. It gives a natural reason for two events spaced years apart. No need for new forces. Just dark matter doing something it might already do. 4. Lorentz symmetry violation, the universe's rulebook glitches. Lorentz symmetry is one of the foundational principles of modern physics. It governs how particles move, how time behaves, how space functions. If Lorentz symmetry breaks, even slightly, particles could travel farther than expected, behave differently at extreme energies, take unusual trajectories. A tiny violation could allow an ultra-high energy neutrino to survive a journey through Earth that should kill it. No new particles needed. Just a small crack in the cosmic rulebook. This theory is mathematically exotic, but not absurd. 5. Earth emergent particles, a new category entirely. Some theorists propose something even simpler. Anita detected a particle we've never seen before. Not a tau, not a stau, not dark matter, not a sterile neutrino. A new particle, let's call it X, that travels long distances through dense matter, decays near the surface, produces a radio pulse, leaves no other traces. X is not a glamorous name, but it's a realistic category. Things we haven't discovered yet. Physicists use letters when they're not ready to commit. 6. Cosmic strings, topological defects, and early universe echoes. These are the most exotic, but still technically scientific hypotheses. They suggest that Anita might have seen the signature of a cosmic string snapping, a ripple left over from the early universe, a topological defect releasing energy. These ideas border on philosophical, but they're not impossible, just rare and hard to test. 7. The theory no one wanted to admit. After all these possibilities were explored, one final explanation remained. Maybe the standard model is incomplete at ultra-high energies. Simple, uncomfortable, the kind of conclusion physicists approach slowly like a suspicious animal. It doesn't mean physics is broken. It means we found the edge. A place where our equations stop being perfect approximations and start being only mostly right. Anita might not have found a particle. It might have found a boundary. The room falls silent. By the time all these theories hit the journals, the mood within the physics community had shifted noticeably. What began as probably nothing had become, it's definitely something. And that was the moment Anita's anomaly transformed from a curiosity into a legitimate scientific mystery, one with enough weight to attract new experiments, new funding, and new generations of physicists eager to solve it. When the first wave of theories hit the journals, the scientific community found itself doing something it rarely enjoys. Sitting in the uncomfortable middle ground between nothing to see here and the universe just handed us a new rule. Scientists are not allergic to mysteries. They just prefer mysteries with expiration dates, ones that resolve themselves with a clever calculation or a better calibration. Anita's anomaly refused to behave that neatly. Instead, it sat there in the data like a polite but unwelcome guest, quietly refusing to leave, and so the debate began. 1. The It's Nothing camp. This group wasn't dismissive, they were cautious. Their argument was simple. Two weird signals are not enough to challenge physics. They suggested extremely rare tau neutrino events, odd scattering patterns inside the ice, statistical flukes, mismodeled Earth density profiles, or some combination of tiny errors, all theoretically possible, but all requiring coincidences stacked like dominoes. Their tone was basically, we don't like this mystery, so let's assume reality is being difficult. It wasn't unreasonable, just unambitious. 2. The "it might be something" camp. This group wasn't reckless, they were curious. They pointed out, Anita saw two nearly identical upward-moving pulses. IceCube's archives contained similar outliers. The standard model struggled to explain the geometry, and the odds of two flukes were absurdly small. They weren't claiming new physics, just acknowledging that the puzzle was too elegant to ignore. Their tone was, this is weird, let's treat it like it's weird. 3. The tension between rare and impossible. This is where the debate sharpened. Camp A said, rare events happen. Camp B said, yes, but impossible ones don't. Physics thrives on probabilities, and the probability that two Anita events were standard neutrinos emerging upward through Earth was so low it bordered on comedic. We're talking lottery odds for a solar eclipse occurring during an earthquake while a meteor hits your mailbox. Yet there they were, two signals clean as polished glass. This is why the anomaly survived, not because it was dramatic, but because it was precise. 4. Enter the statistical pileup. Eventually, a few key papers shifted the tone entirely. One analysis concluded that, under the standard model, the likelihood of Anita's events being normal tau neutrinos was less than 1 in 10 million. Another found that combining Anita's data with IceCube's strange upward-leaning events produced a tension that was statistically meaningful, enough to raise eyebrows in a field where eyebrows are usually glued down. A quiet consensus began to form. We don't know what this is, but we know what it isn't. 5. IceCube complicates the story again. IceCube didn't confirm Anita. It didn't deny Anita. It did something worse. It rhymed with Anita. And scientists hate rhymes. Rhymes suggest patterns. Patterns suggest structure. Structure suggests explanation. But no explanation fit perfectly. IceCube's odd events weren't identical to Anita's, but they nudged the mystery forward, enough for some physicists to mutter, okay, now we have to take this seriously. A mystery is one thing. A multi-detector mystery is another. 6. The shift. No one talked about out loud. By the end of the second Anita flight, something subtle had changed in the field. You could feel it in conference-side conversations, tight-lipped interviews, grant proposals, late-night emails, new theoretical papers. Not excitement, not fear, just attention. The kind reserved for mysteries that are clean, persistent, and scientifically inconvenient. Anita's anomaly wasn't waving a flag, it wasn't screaming for discovery. It was whispering, and physics listens to whispers more carefully than shouts. 7. When scientists become philosophers. Eventually, the conversation expanded beyond equations. People began asking bigger questions. How complete is the standard model really? What if neutrinos behave differently at extreme energies? What if there are long-lived particles we simply haven't looked for? What if ultra-high energy cosmic events produce physics we haven't modeled yet? What if the Earth itself occasionally emits rarer particles? None of these questions were fringe. These were the kinds of questions that launched decades of research. Anita hadn't solved anything, but it had opened a door, a small, stubborn, tantalizing door. 8. The consensus nobody wanted, but everyone accepted. By the time the dust settled, the field had quietly agreed on one thing. Anita's signals are real, and physics cannot explain them with confidence. Not yet. That's why the anomaly survived peer review. That's why it made headlines. That's why it's still discussed today. Not because it's sensational, but because it's unresolved. In science, unresolved is powerful. Unresolved is fuel. 9. The stage is set. With the debate simmering, the theories multiplying, and the anomalies refusing to vanish, the Anita mystery reached a point where the scientific conversation could no longer stay grounded in equations alone, because whenever a mystery lingers, myths begin to swirl around it, and Antarctica is the perfect breeding ground for myth. A silent continent, a hidden landscape, a strange upward-moving pulse. In the next chapter, we step away from pure physics and into the shadowy folklore that Antarctica has collected for centuries. Stories of ancient civilizations, hollow ice realms, forgotten machines, and legends that cling stubbornly to the map's coldest edges. Chapter 3. Antarctica's Library of Myths. If Antarctica were just cold, barren, and empty, it would be impressive, but it wouldn't be mysterious. What makes it mysterious is the silence, the scale, the inaccessibility, and the fact that almost no one has ever seen what lies beneath miles of ancient ice. A place that large, that untouched, and that brutally private practically invites stories. Humans don't like blank spaces on maps. We fill them quietly, creatively, sometimes recklessly. Antarctica ended up being the last blank space on Earth, and people rushed to fill it with every kind of legend imaginable. Before the continent was even discovered, ancient map makers were already placing a giant southern landmass at the bottom of the world, Terra Australis Incognita, the unknown southern land. To them, the Earth needed balance. Land in the north meant land in the south. Symmetry demanded it. They weren't wrong, just very optimistic. But once explorers actually reached the frozen continent, they found no balmy paradise, no green mountains, no cities carved into stone, just a world of ice that didn't care who you were or what you believed. Unfortunately, or fortunately, depending on your entertainment preferences, myths don't die just because reality is boring. If anything, they evolve. Antarctica very quickly became the perfect canvas for imagination, and the stories that grew out of this place would eventually intertwine with the Anita mystery in ways that are strangely poetic, occasionally absurd, and surprisingly persistent. Let's start with the simplest reason Antarctica attracts myths. Almost nothing that happens here is observable. You can't see beneath the ice. You can't dig easily. You can't explore underground. You can't fly over most regions in winter. You can't detect structures with normal sensors. You can't monitor seismic activity without static noise blasting the signal. Antarctica is one of the few places on Earth where a mountain range can remain unknown until radar hits it at the right angle, where a lake the size of a small country can sit hidden for millions of years, where a cave system beneath the ice can hum like a pipe organ and no one knows why. When a place refuses to reveal itself, myth-making rushes in to fill the vacuum. But there's a second reason too. Antarctica feels ancient in a way that nothing else does. Not historically ancient, geologically ancient, emotionally ancient. Standing on Antarctic ground feels like standing in a world before humanity existed. A world shaped by forces so slow and so massive that you can sense them without seeing them. It's the kind of place where your imagination doesn't need much help to start wandering. If you've ever walked through an empty building at night and felt your thoughts stretch into every shadow, Antarctica is that feeling amplified by an entire continent. This is why every culture, every era, and every generation that encounters this place eventually leaves with the same feeling. There's something different here. And once that feeling sets in, everything becomes suspect. A strange radar echo? Maybe something's down there. A perfectly rectangular subglacial void. That can't be natural, right? A magnetic anomaly? Are we sure that's geology? A seismic tremor with no quake attached? Okay, but what if a radio pulse rising from the deep? Oh, now we're definitely talking. Antarctica is practically engineered for conspiracy theories, not because anything supernatural is happening, but because the environment is so extreme and so hidden that human intuition simply doesn't work here. We evolved in forests, grasslands, mountains, and coastlines, not on frozen alien landscapes. Our instincts misfire, our pattern recognition overreaches, our sense of scale collapses, and myths slip in through those cracks. Some are harmless, some are elaborate, some are wildly imaginative, and some are surprisingly informed. The one thing they all share is this: Antarctica is the perfect setting. It's the last place in the world where mystery feels natural. Which brings us to the stories. Stories that shaped how the public, and even some scientists, reacted to ANITA's upward moving signals. Next, we'll explore the oldest and most persistent Antarctic myth, the idea that beneath the ice lies a hidden world, one that has captivated explorers, occultists, and pseudoscientists for over a century. Long before anyone imagined neutrino detectors drifting above Antarctica, an older story had already taken root, one that still refuses to die no matter how coldly science tries to bury it. It's the idea that beneath Antarctica lies an entire hidden world, not necessarily a civilization, not necessarily an Atlantis, not necessarily anything elaborate, just the persistent belief that the vast ice hides something big, something structural, something intentional. This story appears in dozens of different forms, but they all share one theme. Antarctica is hollow, or partially hollow, or hiding hollow spaces that shouldn't be there. The origins of the idea actually start with something real. Antarctica does have enormous underground voids. Geothermal heat from the Earth melts ice from below. Volcanic activity creates caverns. Subglacial rivers carve tunnels through darkness. Radar surveys map out empty chambers so large researchers compare them to cathedrals or airplane hangars. Science explains these features beautifully. Myth does not care. Early explorers reported strange echoes beneath their feet. Some described the ground vibrating with no wind. Airplanes flying overhead picked up odd radar shadows, long, straight signatures that looked engineered. Seismic readings bounced strangely, sometimes suggesting empty spaces, sometimes suggesting buried ridges that vanished upon remeasurement. Nothing supernatural, just messy data in a harsh environment. But once the idea of vast underground chambers existed, imaginations began to stitch them together into something grander. The Hollow Earth movement moves in. In the 19th and early 20th centuries, a fringe idea called Hollow Earth theory started weaving its way into popular culture. It proposed that Earth wasn't solid all the way through, that there might be inner realms, caverns, entire ecosystems beneath the crust. Does science support this? No, absolutely not. Is it fascinating folklore? Yes, because it blends exploration with existential wonder, and Antarctica became the perfect place for believers to anchor their hopes. It's mostly unexplored. It's full of ice-locked caverns. It has entrance-like features carved by volcanic heat. It hides giant voids under the Ross and Amory ice shelves. A continent with more unknowns than knowns is irresistible to mythmakers. Some claimed there were openings to an inner world at the poles. Others said ancient races fled into the earth when the surface world became unstable. Some stories claim that Antarctica was once temperate, home to forests and freshwater lakes before freezing over, a fact that is, weirdly, scientifically true. The continent was warm millions of years ago, but pseudoscience takes that truth and runs a marathon with it. If Antarctica was warm once, myths ask, what was living here before the ice came? And did any of it survive below? The hidden realm beneath the ice narrative. This is the most flexible, durable version of the myth. It doesn't require aliens, lost civilizations, or mystical powers. It just assumes the ice is hiding something big, something intentionally shaped, something not yet found. When ground-penetrating radar picked up long, straight subsurface lines, the myth seized on them. Perfect geometry is suspicious in a place shaped entirely by wind and ice. When scientists discovered the colossal subglacial lake systems, Vostok, Whillans, Mercer, and hundreds of smaller ones, the myth expanded. Lakes meant ecosystems. Ecosystems meant possible organisms. Organisms meant possible anything. And when researchers found microbial life inside ice cores that had been isolated for millions of years, that was it. The story locked in. If life could survive in those conditions, then who's to say something else didn't survive deeper down? Again, science has answers for all of this, but myth isn't interested in science. Myth is interested in meaning, and meaning loves a vacuum. The hidden realm idea became the backbone for future stories. Stories about civilizations, lost knowledge, ancient machinery, and sometimes castle-sized chambers warmed by volcanic vents. And eventually, many of these stories merged into one powerful, durable narrative. Antarctica is not empty. Antarctica is hiding something, which makes it the perfect stage for an anomaly like Anita's. If a signal rises from beneath the continent, a place already thick with rumors of something down there, myth breathes a little deeper. But that's only one category of legend. If the hollow ice myth explains where a hidden world might be, the second great Antarctic legend explains who might have lived there. This is where Antarctica's mythology shifts from geology to culture, where frozen mountains become ancient ruins, radar shadows become buried structures, and scientific caution becomes a blank page waiting to be filled by human imagination. The idea is simple, irresistible, and has survived for generations. Antarctica was once home to a civilization that predated known history. Not necessarily advanced, not necessarily alien, not necessarily magical, but older, much older This story isn't random. It has roots in real science, then gets stretched into myth. Let's walk through how that happened. 1. Antarctica was once warm, and that changed everything. Millions of years ago, Antarctica wasn't a wasteland. It was green, forests of beech and conifer, freshwater lakes, rivers flowing through valleys, a climate similar to modern-day New Zealand. There were trees, insects, flowering plants, amphibians, and even dinosaurs. This isn't speculation. This is fossil record. So when early 20th century scientists discovered petrified forests and leaf imprints in the trans-Antarctic mountains, the story exploded in the public imagination. If the continent was warm once, could people have lived there? The science says humans didn't exist yet. The myth says details, and just like that, the seed of a legend was planted. 2. Ancient maps added fuel to the fire. Enter the Piri Reis map, a 1513 world map that some claim depicts the coastline of Antarctica without ice. Historians disagree, cartographers disagree, actual geographers practically throw things. But to myth makers, the details didn't matter. The idea stuck. How did a 16th century map maker know about Antarctica's coastline? Never mind that the map probably shows South America with artistic distortion. The myth never let go of this one because it offered a tantalizing possibility. What if someone mapped Antarctica before it froze? And if someone mapped it, were they living there? Thus emerged the legend of an unknown maritime civilization that charted the world long before recorded history. No artifacts, no ruins, no evidence, but a stubborn idea that refuses to disappear. 3. The Atlantis connection. When people run out of places to put Atlantis, they almost always shove it into Antarctica. It's cold, empty, hidden, unexplored, and massive, perfect for a lost empire. Some versions claim Atlantis was originally a southern continent. A cataclysm sent it drifting to the pole. The freeze buried it. The remnants lie under kilometers of ice. Science disagrees, obviously, but myth loves pattern matching, and the pattern is simple. Hidden land plus ancient climate plus mysterious radar echoes equals Atlantis, apparently. At least once a decade, some corner of the internet erupts with claims of ruins detected under the ice. They usually turn out to be rock formations, sastrugi, wind-shaped snow, crevasse fields, pixel glitches, or someone misreading satellite shadows. But the myth continues, because Antarctica feels like the kind of place where Atlantis should be hiding. Even scientists sometimes sigh at how persistent this one is. 4. The civilization with advanced technology, aka ice shapes that look like shapes. Whenever satellite images show a straight line, a smooth dome, an angular ridge, a geometric shadow, or anything that doesn't look like jagged ice, you can guarantee that within hours, someone online will label it an ancient building. There was a famous viral image of a long, narrow, rectangular structure said to be 500 meters long. It turned out to be a crevasse with unusual wind scouring. Another claimed Antarctic pyramid became internet famous. It was just a nun attack, a mountain peak poking through ice. But again, myth feeds on visuals, not geology. If something looks like architecture, the story writes itself. Some versions go even further, suggesting the civilization possessed megastructures, energy chambers, crystalline machines, or libraries of lost knowledge. No evidence supports any of this, but the mythology doesn't require evidence. It only requires the sense that Antarctica feels like the kind of place where forgotten things could remain frozen in time. 5. The pre-human civilization concept. A smaller, quieter branch of the myth suggests that Antarctica housed a civilization that existed before humans. Not aliens, just an evolutionary branch we never encountered. These stories say an intelligent species arose here. They built structures. Climate collapse drove them underground or into extinction. Ice entombed the remnants. This version is almost anthropological, like a prehistoric footnote lost to glacial time. Again, no evidence. But the lack of evidence is exactly what keeps the myth alive, because Antarctica is one of the only places on Earth where you can completely bury a civilization under 3 miles of ice and no one would ever know. 6. Why this myth clings to the ANITA story. When Anita detected signals rising from beneath Antarctica, myth makers immediately stitched this anomaly into their narrative. If something is under the ice, anything at all, it might produce energy, signals, or emissions. And while scientists disagree, you can't blame the public for noticing how neatly the ANITA anomaly fits into mythic geography. A continent full of legends, a set of upward-moving signals from deep below, a history of unexplored voids. Could the two be related? Science says no. Myth says maybe. The human imagination says absolutely. And the truth is, Antarctica is mysterious enough without embellishment. But speaking of embellishment, the next segment explores one of the strangest, most persistent Antarctic legends of all time, the one involving secret bases, wartime expeditions, and rumors that still circulate today, despite being thoroughly debunked. If lost civilizations are the oldest Antarctic legend, the most persistent modern one is much more cinematic. It reads like a thriller novel, survives on half-truths, and resurfaces every time someone posts a blurry satellite image. It's the myth that Antarctica hides secret bases built during World War II, and that what happened there is still classified today. This entire legend has been debunked every which way, but myth doesn't dissolve when you debunk it. Myth dissolves when people get bored, and Antarctica never lets anyone get bored, so the story lives on. Let's walk through how it started and why it still gets brought up every time a strange signal shows up beneath the ice. 1. The 1930s to 40s expeditions set the stage. In the late 1930s, multiple countries launched expeditions to Antarctica. Most were scientific, but some had geopolitical motives, claiming territory, mapping coastlines, studying resources. One expedition in particular, led by a certain 1930s-era European power, has been exaggerated endlessly online. In reality, it was a standard mapping mission. But myth has a way of turning mapping into constructing underground superbases. The truth, they dropped flags, photographed the coastline, and left. The myth, they built underground tunnels, found ancient technology, and hid things the world wasn't ready for. The gap between those interpretations is vast. 2. Operation High Jump, the oxygen mythologists' superfuel. After World War II, the United States launched a massive scientific and military-supported mission to Antarctica called Operation High Jump, 1946 to 47. It was big, expensive, and fast-paced. Perfect ingredients for conspiracy theorists. The real purpose: test equipment in cold environments and train personnel. The mythic purpose, depending on who you ask: wipe out a hidden base, investigate strange aerial phenomena, recover ancient relics, or confront something down there. Some versions of the story even claim flying disc-shaped craft appeared during the mission. Pure fiction, but persistent fiction. High Jump couldn't have gone more predictably wrong for myth control. Accidents happened. Aircraft crashed. The mission ended earlier than planned. All of this got folded neatly into the narrative that something happened down there. The dull truth: extreme weather and bad luck. The myth: a secret confrontation with forces unknown. 3. The warm caverns rumor. One detail that supercharged these myths was real geology. Antarctica has volcanic activity, geothermal vents, underground caverns kept warm by heat, subglacial tunnels carved by melted water. Scientists talk about these calmly. Conspiracy theorists talk about them dramatically. Warm caverns became secret hideouts. Volcanic vents became energy generators. Subglacial tunnels became underground rail systems. If you squint hard enough at scientific facts, you can turn them into fiction with very little effort. And once Anita detected an upward-moving signal, people immediately connected the dots in imaginative ways. Maybe the pulses are coming from machinery. Maybe something buried down there is still active. Maybe humans aren't the only ones using the caverns. To scientists, this was noise. To storytellers, it was fuel. 4. The classified archives problem. Every government keeps archives classified for decades. It's standard protocol. But whenever anything related to polar research remains sealed longer than expected, mythmakers pounce. The thinking goes like this: if it's classified, it must be dramatic. If it's dramatic, it must involve technology. If it involves technology, it must involve the ice. The far more boring reality: classified files usually contain personnel mistakes, equipment failures, political maneuvering, embarrassing logistics, or just budget issues. But Antarctica has such mythic sway that even mundane patents and project logs ignite speculation. 5. Why this myth still clings to Anita. When Anita detected upward-moving signals, anyone already invested in the hidden base mythology immediately reinterpreted the anomaly as an underground device activating, an artificial energy burst, machinery operating beneath the ice, interference with experiments, or even an intentional communication. Science offers nothing to support these claims. The signals match no technological emissions. The energy is wrong. The timing is random. The physics is natural. But myth isn't looking for physics. It's looking for stories, and the Anita anomaly, clean, geometric, unexplained, fit perfectly into a mythic template that had been simmering for decades. Something under the ice woke up. If you already believe something is buried in Antarctica, ANITA becomes the missing puzzle piece. If you don't, it becomes an interesting coincidence. Either way, the myth and the science became entwined, two parallel narratives orbiting the same continent, occasionally brushing against each other but never fully connecting. 6. The real reason. These myths persist. It isn't because people want to believe lies. It's because Antarctica feels incomplete. A place so vast and inaccessible makes the imagination restless. Anything could be down there. Nothing could be down there. Both feel equally plausible from the human perspective, and as long as that emotional truth exists, no amount of data will fully erase the mythology. But myths are only one layer. Antarctica also has legends, stories whispered among explorers, scientists, and locals of remote outposts that aren't meant to be factual or conspiratorial. They're simply stories born from a landscape that invites wonder. Next, we'll explore those. The soft, eerie, timeless legends that live in the solitude of the ice. Not all of Antarctica's stories are grand or conspiratorial. Some aren't about lost civilizations, hidden worlds, or secret bases at all. Some are smaller, quieter, born from the simple experience of living in a place that feels disconnected from the rest of the planet. These are the legends shared in research stations late at night, passed between expedition crews, or spoken by people who've spent just a little too long surrounded by white horizon in every direction. They're not meant to be believed, literally. They're meant to capture the feeling of Antarctica, the sense that the landscape itself has moods. Let's explore a few. 1. The singing ice. Many researchers have heard it, the deep, resonant hum that travels through the ground like a heartbeat. It's caused by wind vibrating the surface layers of the Ross ice shelf, but the sound doesn't resemble wind. It resembles a distant choir, a low organ note, or the rumble of something impossible, huge, shifting in sleep. Some swear that if you stand still long enough, the ice seems to breathe. Not literally, but rhythmically, like the continent has its own pulse. Scientists explain it calmly, but no one forgets it. 2. The whiteout footsteps. Some who've wintered over report hearing footsteps during thick whiteouts, one of the most disorienting phenomena on Earth. In a whiteout, you can't see the ground beneath your boots, the sky above your head, or the station behind you. The world becomes a swirling void of featureless brightness. In that kind of sensory deprivation, the mind gets creative. People describe footsteps pacing behind them, someone knocking lightly on the wall of a tent, soft crunches in the snow nearby, even though no one is out there. No one can be out there, it's just the wind, reshaping snow, playing tricks. But the legend persists. The ice remembers every footstep ever taken on it, and sometimes it plays them back. 3. The compass drift. Old explorers used to tell stories of compasses misbehaving violently in Antarctica. Modern science explains this easily: magnetic anomalies, shifting magnetic declination, and ionospheric interference. But the legends say something else. The poles don't just pull compasses, they confuse them, as if the continent has a way of rewriting direction, not maliciously, just indifferently. A reminder that you are not the one navigating here, the Earth is. 4. The shadow that isn't there. Researchers working near the Transantarctic Mountains sometimes describe a strange optical effect, shadows appearing where nothing can cast a shadow. Not hallucinations, real atmospheric refractions, light bending through layers of cold air. Mirages made not of heat but of ice. Mountains appear where there are none. Dark shapes drift across the horizon and dissolve. Ridges seem to rise and fall like tides. One legend says, Antarctica shows you landscapes from its memory, not its present. Again, poetic, not literal, but spend a dusk in the polar plateau and you'll understand why the story exists. 5. The subglacial whispers. Seismic sensors often pick up strange vibrations under the ice. Usually they're caused by shifting glaciers, cracking ice shelves, distant quakes, meltwater moving. But in the early days of research, long before modern instruments, expedition crews claimed to hear faint sounds in the stillness, tapping, distant hums, the occasional echo like stone hitting stone. Nothing supernatural, just the planet stretching and settling. But Antarctica has a way of turning natural noises into myths, especially in winter when darkness lasts for months and the nearest human is hundreds of miles away. These stories aren't about belief, they're about atmosphere. They capture what it feels like to stand on a continent that doesn't care you exist, a continent that reveals itself only when it wants to, and even then, only partially, a place where science works hard, but imagination works harder. And when Anita detected an upward moving signal, all these legends, the whispers, the footsteps, the singing ice, the mirages, suddenly gained a new layer of resonance. Because the moment the anomaly entered public awareness, the myths rushed to meet it. The scientists said, "We detected a strange signal." The myths said, "Of course you did." In the next chapter, we return to the scientific side of the story, because myths are fun, but Anita's anomaly isn't explained by folklore. It's still a physical mystery. And Chapter 4 explores what the anomaly means for the future of science, the future of Antarctica, and the future of our understanding of the universe. Chapter 4: What the signal might mean. By the time Anita's anomaly settled into the scientific consciousness, the world had split into two narratives. The scientific version, upward-moving particle showers that don't fit existing models. The mythic version, something beneath the ice is sending messages. The truth sits quietly between them, not dramatic, not cinematic, but genuinely astonishing in a calm, understated way. Because what Anita detected is, in its own quiet way, one of the most intriguing scientific mysteries of the century. Not because it suggests lost civilizations or ancient machines, but because it suggests we're brushing up against a boundary, a place where our current physics, beautiful, reliable, mathematically precise, starts to feel like a map that ends just a bit too early. This is the part of the story where we zoom out and look at the big picture, not the noise, not the speculation, just the landscape of possibilities. And the possibilities are fascinating. 1. The standard model might be leaking. The standard model of particle physics is one of the most successful frameworks humans have ever built. It predicts the behavior of dozens of particles with absurd accuracy. But everyone in physics knows the same uncomfortable truth. The standard model is incomplete. It doesn't explain dark matter, dark energy, gravity's behavior at quantum scales, the universe's early expansion, neutrino mass, or why the constants of nature are the values they are. It works beautifully until it suddenly doesn't. Anita's upward pulses don't break the standard model, but they push against its edges. They probe energies so extreme that the model gets shaky. If the anomaly holds, it might suggest new neutrino interactions, modified cross-sections at ultra-high energies, physics that only appears in rare cosmic circumstances, not dramatic but deeply meaningful, like finding a small crack in a perfectly smooth wall, a signal that something lies behind it. 2. Ultra-high energy neutrinos might behave differently than expected. Neutrinos are already the strangest particles in the known universe. They oscillate, change flavors, pass through entire planets like light through glass. Even under normal conditions, they play by their own rules. At ultra-high energies, where cosmic rays slam into the universe at velocities that humans cannot reproduce, neutrinos may reveal behavior we simply haven't modeled correctly yet. Anita might have seen a rare neutrino state, an interaction that only occurs at ultra-high energies, or a neutrino that passed through Earth in a way that defies our current math, but not reality. Sometimes physics doesn't need new particles, it just needs new equations. 3. We might be seeing the echo of a cosmic event. One possibility that fascinates astrophysicists is the idea that Anita caught the tail end of a cosmic event so extreme that it altered particles in ways we don't yet understand. Something like the decay of a super-heavy relic particle, debris from an ancient cosmic phenomenon, or a shockwave from high-energy astrophysical processes. In this view, the signal isn't local. It isn't Antarctic, it isn't geological, it's cosmic, something that began millions of years ago, light years away, and happened to end by pure coincidence under the ice. The universe is enormous. Coincidence is not impossible, just improbable enough to be interesting. 4. The beginning of new physics. A very carefully used term. Physicists avoid the phrase new physics unless they mean it, but Anita's anomaly opened the door to that phrase, not as a declaration, but as a possibility worth examining. New physics doesn't mean sci-fi spectacle. It usually means subtle shifts, asymmetry breaks. An interaction varies. A constant isn't constant at extreme energies. Small adjustments that ripple outward into major discoveries. Anita might be the first hint of a new particle family, evidence of interactions outside our detector's previous ranges, a clue pointing to uncharted territory. Not a revolution, a refinement, but refinements are how revolutions begin. 5. The value of a clean mystery. One of the reasons Anita's signal matters so much is that it's clean. Clean waveform, clean angle, clean physics signature. Clean mysteries are rare. Most anomalies in science vanish when examined. This one didn't. It held up under scrutiny. It passed peer review. It continues to resist easy answers. That alone makes it scientifically precious. 6. A reminder of how little we truly know. If this story has a theme, it's humility. The earth still surprises us. The universe still surprises us. Even ice, frozen water still surprises us. A balloon drifting over Antarctica caught a signal rising from beneath a continent we barely understand, a signal that should not exist but does. It doesn't need to be supernatural. It doesn't need to be mythical. It doesn't need to reveal an ancient civilization. Its importance lies in what it asks. Are we sure our model of the universe is complete? And historically, whenever humanity has confidently said yes, the universe has responded with a polite, quiet, well-timed actually. Anita might be one of those actually moments. a gentle reminder from reality that our understanding, while impressive, is still just the beginning. Next, we'll explore the institutional reaction, what scientists planned next, what new experiments were proposed, and how Antarctica became a focal point for future investigations. When Anita's anomaly circulated through the scientific community, nobody sprinted to rewrite the textbooks. That's not how science works. Scientists do not rush. They inch forward, slowly, stubbornly, sometimes painfully, until the evidence forces a larger step. But Anita's data did immediately spark something that scientists rarely show openly: curiosity with stakes. Because this wasn't a blurry photo or anecdotal sighting. It was a well-documented, peer-reviewed, reproducible anomaly. The kind that doesn't fade away when someone checks the math. So the global physics community responded in the only way it knows how, with meetings, papers, debates, seminars, preprints, and the occasional stressed-out email typed at 3:41 a.m. Let's look at how that response unfolded. 1. The conferences took notice. The first place the anomaly found traction was at neutrino conferences, those gatherings where brilliant people talk about particles that almost never interact with anything, including the detectors trying to observe them. When Anita's upward-moving signal was presented, it caused raised eyebrows, muttered discussions, hallway debates, requests for data access, and polite but pointed questions. In scientific terms, that's the equivalent of fireworks. Researchers love puzzles. They especially love puzzles that don't evaporate when reanalyzed. The anomaly made it clear we don't have the full picture yet. That's enough to electrify an entire field. 2. Ice Cube quietly reopened its archives. Ice Cube wasn't built for Anita's puzzle, but it became crucial to solving it. After the second Anita anomaly, Ice Cube teams went back through years of data, thousands of events, to look for anything that rhymed with Anita's geometry. They didn't find a perfect match, but they found enough weak echoes, strange, steep angle events, to make the puzzle deeper instead of simpler. This did two things: validated Anita's legitimacy, expanded the mystery beyond a single experiment. Whenever one detector finds an anomaly, it's interesting. When two detectors find similar anomalies, now you have a research direction. 3. New experiments were proposed. Scientists don't treat mysteries as threats, they treat them as opportunities. Within months of the ANITA publications, researchers began proposing follow-up missions. Anita 4 and upgraded balloon flights, more sensitive arrays, better noise rejection, and improved calibration. If the anomaly appears again, the mystery strengthens. If it doesn't, the mystery shifts. B. Ice Cube Gen 2. A dramatic expansion of Ice Cube, more detectors, deeper arrays, better coverage. Designed partly to see if Anita's upward events can be caught from below. See Beacon and Puyo experiments. Ground-based and balloon-borne detectors specifically designed to catch upward bursts. D-radar and seismic follow-ups. Not hunting for civilizations, just verifying ice structure and eliminating unusual geological interference. The ultimate message was simple. We need more eyes on the ice. 4. Some physicists took theoretical risks. In most fields, proposing a risky theory is professional danger. In particle physics, it's Tuesday. Dozens of theoretical papers appeared in the wake of Anita's anomaly. Supersymmetric scenarios, sterile neutrino models, Lorentz-violating frameworks, decay pathways for ultra-heavy particles, Earth emergent exotic particle hypotheses, none claimed to be correct. All acknowledged uncertainty, but the mere fact that highly credentialed physicists were publishing these ideas showed how seriously the anomaly was being taken. You don't propose new physics unless something pushes you convincingly toward the door. Anita nudged a lot of people toward that door. 5. Antarctica became a scientific hotspot again. Antarctica has always been important for climate science and geology, but Anita made it important for particle physics too, and that shifted priorities. New funding targeted ultra-high energy neutrino detection. More stations began sharing data across countries. Balloon missions gained institutional support. Deep ice drilling programs expanded. Interdisciplinary projects formed between geology and astrophysics. In other words, Anita caused a quiet scientific pivot, not a revolution, just a refocusing, a recognition that Antarctica might be one of the best places on Earth to study the universe's strangest particles. 6. The what-if questions became harder to ignore. Scientists started engaging with uncomfortable but necessary questions. What if the Earth occasionally emits particles we don't understand? What if ultra-high energy physics operates under different rules? What if neutrinos behave differently when interacting with dense media? What if cosmic rays produce rare particles that slip through Earth? What if the Anita events represent a class of phenomenon we've never studied? These aren't mystical questions. They're scientific ones, mathematically grounded, experimentally testable, and the more they were asked, the more legitimate the mystery became. 7. The one thing everyone agreed on. Despite debate, disagreement, and dozens of competing theories, the community did converge on a single point. The anomaly warrants further investigation. That is the scientific equivalent of a standing ovation. Scientists rarely agree on pizza toppings, let alone particle anomalies. The fact that a balloon flying over Antarctica made global physics pause says everything you need to know. 8. A mystery that doesn't demand drama. Even stripped of myths, stripped of conspiracies, stripped of speculation, the ANIT, A signal, is still extraordinary because it represents something rare, a moment where nature hands us a puzzle and waits patiently for us to catch up, not with panic, not with fanfare, just with curiosity. What the signal means is still unclear. It could be new physics, it could be a rare standard model event, it could be the first sign of something bigger, but it is undeniably worth following. To understand why Anita's anomaly feels so significant, you have to zoom out far beyond Antarctica, beyond Earth, beyond even the solar system itself, because upward moving pulses that defy our models aren't just Antarctic curiosities, they're cosmic breadcrumbs. Signals like these are whispers from the universe's most extreme environments, the kind of environments that don't just push physics to its limits, they shatter those limits, rebuild them, and then casually scatter particles across millions of light years like cosmic postcards. If Anita really did catch something new, it might not simply be a mystery about ice. It might be a message about the universe. Let's explore what ANITA's anomaly might imply on a grander scale. 1. Ultra-high energy neutrinos, the universe's most subtle messengers. Most particles in the cosmos are noisy. They crash, smash, collide, and announce themselves violently. Neutrinos are the opposite. They are quiet, shy, introverted particles that pass through stars, galaxies, and planets without so much as a whisper. But ultra-high energy neutrinos, those are different. They come from supermassive black holes, active galactic nuclei, gamma-ray bursts, star-obliterating cosmic events, unknown astrophysical processes we don't have names for yet. They are rare, difficult to detect, and incredibly valuable. Catching even one is like receiving a message written at the edge of the universe. So if Anita's anomaly came from an ultra-high energy neutrino, it may be telling us something about events unimaginably far away, something old, something violent, something powerful, a distant origin for a signal detected beneath the ice. 2. The Earth as a detector, whether it wants to be or not. One unintuitive idea in this story is that Earth itself acts as a neutrino detector. When ultra-high energy cosmic particles slam into the planet, the crust absorbs some, the mantle alters others. A few rare ones produce cascades detectable from above. In this sense, Anita didn't catch a signal from Antarctica. It caught a signal produced by the Earth's interaction with the cosmos. That's why the anomaly matters. It means something high energy passed through us, not in a dramatic way. No danger, no risk, no interference. Just a faint signature of the universe brushing against our planet. It is humbling, in a quiet way, that we can even detect such things. 3. A glimpse into physics at energies we cannot reproduce. Particle accelerators, like the Large Hadron Collider, are powerful, but they are still fragile toys compared to the universe's own machinery. Cosmic rays can reach energies millions of times higher than anything humans have ever produced. At those energies, particles behave differently, interactions shift, rare processes activate, theoretical models get fuzzy, new physics might emerge naturally. Anita may have accidentally glimpsed conditions we simply cannot create artificially. That alone makes its anomaly valuable, because it opens a window into a realm of physics we've only ever theorized about. 4. A clue about the composition of the universe. If Anita's events were caused by exotic particles, dark matter decay, sterile neutrinos, supersymmetric particles, or unknown cosmic debris, it would directly inform one of the biggest open questions in science. What is the universe actually made of? Right now, 5% is normal matter, 27% is dark matter, 68% is dark energy, and we don't actually know what any of that means in practical terms. A single exotic particle event, just one, could provide a vital clue, not because the particle is powerful, but because it might be different. Anita's anomaly might represent that difference. 5. The possibility of a new class of cosmic particle. This is one of the most exciting, but still responsible, interpretations. Anita may have detected a particle we've never encountered before. Not science fiction, just science expanding. The universe is under no obligation to only contain particles we've discovered. In fact, history suggests the opposite. Electrons were once unknown. Neutrinos were once unknown. Quarks were once unknown. Higgs bosons were once unknown. The pattern is clear. Every few decades, we find something new. Anita might be pointing toward the next discovery, not with drama, but with a gentle upward pulse caught by antennas drifting above the ice. 6. Cosmic rarity makes the anomaly more meaningful. The rarity of Anita's signals is part of what makes them scientifically compelling. If Anita had detected dozens of anomalies, scientists would assume noise or equipment error. But two separated in time with nearly identical signatures, that's the kind of rarity that physics pays attention to, because the universe often hints at new phenomena through whispers, not shouts. 7. The signal's origins might still be unknown, but that's the point. Science does not demand immediate answers. It demands good questions. And Anita's anomaly gave us one of the best questions of the last 2 decades. What particle can pass upward through the Earth at ultra-high energies? We don't know the answer yet, but the search for that answer is already reshaping experiments, funding, missions, and future detectors. Sometimes the value of a mystery isn't the revelation at the end, it's the scientific revolution it motivates along the way. 8. Antarctica becomes a cosmic observatory. One of the unexpected consequences of Anita's anomaly is this. Antarctica is now viewed as one of the best places on Earth to study extreme cosmic physics. Why? The ice is radiotransparent, the air is clean, noise is minimal. Detectors can use ice as a massive detection medium. Cosmic particles interact dramatically with snow and ice. Anita's mystery helps solidify Antarctica's place in the future of astrophysics, a continent of ice, becoming a gateway to the extreme universe. At this point, you might expect scientists to be frustrated by Anita's anomaly. 2 signals, no explanation, and 1,000 theories pointing in different directions. But the truth is far more human and far more interesting. Scientists like mysteries. They don't like being wrong, of course, but they love being surprised. Surprises mean there's more to learn, more to explore, more to understand. And Anita's anomaly, in its quiet, upward moving way, reminded the world of something science occasionally forgets. The universe does not owe us simplicity. Let's look at how this mystery reflects the deeper emotional and philosophical layers of scientific work. 1. Uncertainty isn't a weakness. It's the engine of progress. You might imagine science as a machine that produces answers, but in reality, science is a machine powered by uncertainty. Every meaningful discovery in history began with a moment like Anita's. That's strange. We don't have a model for that. Why did that happen? That's not supposed to do that. Uncertainty doesn't derail science. It drives it. And Anita provided a rare, elegant uncertainty, clean data, no easy explanation, and a result that forces deeper thinking rather than shallow speculation. 2. Mysteries keep the scientific imagination alive. Even the most logical, mathematically trained physicists have imaginations. They don't picture dragons or ancient empires. Well, sometimes they do. But mostly they picture exotic particle states and strange geometries. Anita lit that imaginative spark. It nudged physicists into asking, what if we're missing a particle? What if neutrinos behave differently inside the Earth? What if ultra-high energy events open hidden windows in the laws of physics? What if the universe is richer, stranger, and more layered than our equations predict? These aren't fantastical questions. They're the natural result of wonder, and science needs wonder just as much as rigor. 3. Mysteries provide a reality check. When a field becomes too comfortable, too confident, or too set in its ways, reality has a habit of nudging it back into humility. Anita's anomaly felt like one of those nudges. The scientific community had spent decades reinforcing the standard model, testing it, perfecting it, pushing it, celebrating its accuracy. And then, from above the coldest place on Earth, a balloon said, "Actually, here's something weird." It wasn't a rebuke, just a reminder that the universe doesn't follow our frameworks. Our frameworks follow the universe. 4. The beauty of not knowing. Scientists often describe a strange paradox. The most exciting part of a discovery is not the answer, but the moment right before the answer. The moment where everything is possible and nothing is confirmed. Anita placed the scientific world in that space, not knowing whether the signal came from new physics, a rare neutrino, an exotic particle, or something we haven't even conceptualized yet, creates a sense of open possibility, a lightness, a curiosity, a collective breath held gently in the darkness of the unknown. It's almost meditative, almost poetic, a reminder that the universe still has secrets. 5. Mysteries unite people more than answers do. Every physicist can tell you collaboration doesn't always come naturally. Fields fracture, theories compete, institutes argue, funding divides, but mysteries unite people. Suddenly everyone is working on the same question. Everyone is curious about the same anomaly. Everyone wants to understand the same signal rising from beneath the ice. Anita created conversations between theorists and experimentalists, neutrino physicists and cosmic ray researchers, Antarctic geologists and astrophysicists, balloon engineers and particle modelers. People who normally wouldn't cross paths were suddenly comparing notes, asking questions, and examining each other's assumptions. Few things bring the scientific world together the way a clean, unexplained signal does. 6. The humility of a quiet universe. There's something fitting, almost poetic about the fact that one of the most intriguing anomalies of the modern era wasn't discovered in a giant underground collider or a billion-dollar space telescope. It was found by a balloon drifting quietly above a continent of silence. No drama, no spectacle, just antennas listening to ice. It's a reminder that the universe doesn't need to shout to be profound. Sometimes it whispers, and you have to be in the right place, looking in the right direction, to hear it. 7. The view from the ice. When researchers discuss Anita, there's a recurring sentiment, spoken softly, with a kind of reverent admiration for the landscape. If something strange were to reveal itself anywhere, it would be here. Antarctica feels like a threshold, a boundary, a liminal place where Earth touches the edge of the unknown. It's fitting that the mystery came from this place. Fitting that the signal rose from the deep. Fitting that the continent known for silence offered a whisper that echoed across science. By now, Anita's anomaly has taken us on a strange kind of journey, one that begins under miles of Antarctic ice and ends in the farthest reaches of the universe. It's a journey that loops through physics, mythology, geology, and human curiosity before returning to the same central truth. We don't yet know what the signal was, but we know it mattered. This final segment of Chapter 4 looks at that meaning, what Anita's anomaly represents not as a problem to be solved, but as a signpost pointing toward the future of scientific exploration. 1. The importance of not yet. When a mystery like this appears, there's a natural temptation to demand answers. to force a conclusion, to insist that science turn the unknown into the known as quickly as possible. But that urgency misunderstands what mysteries are for. Sometimes the most scientifically valuable answer is not yet. Not because scientists are stalling, not because the data is bad, not because the anomaly is flimsy, but because patience is part of discovery. If the universe were eager to reveal everything at once, it wouldn't be this interesting. The beauty lies in the deliberate pace. Anita gave us a mystery that demands time, and that alone makes it meaningful. 2. A signal that created new questions. Most scientific discoveries answer questions. This one did the opposite. Anita triggered new questions. What particles can traverse Earth at extreme energies? How do neutrinos behave in extreme environments? Are there cosmic interactions we haven't modeled yet? Could exotic particles exist in small but detectable quantities? Are our assumptions about cosmic scale physics too rigid? What instruments do we need to observe these events properly? These questions don't close doors, they open them. And every open scientific door leads somewhere, even if we don't know where yet. 3. The balloon that pointed toward tomorrow. There's something almost humorous about the fact that a cutting-edge discovery came from an instrument that looks like something a wizard might design in a fantasy novel. A massive balloon, drifting through the stratosphere, carrying antennas pointed at the ice. No lab, no underground tunnel, no super collider, just quiet technology floating in quiet air above a quiet continent. And yet, this simple platform gathered data powerful enough to disrupt assumptions and redirect entire research fields. It's a reminder that innovation doesn't always require force. Sometimes it requires altitude. 4. A mystery, big enough to matter, but small enough to handle. Anita's anomaly sits in a rare scientific equilibrium. It's not dramatic enough to cause panic. It's not mundane enough to dismiss. It's not obvious enough to explain. It's not wild enough to spark pseudoscientific frenzy among researchers. It's just right, a manageable mystery. A puzzle with clear edges, a piece of data that refuses to be ignored, but also refuses to be exaggerated. These are the mysteries that shape a field quietly over decades. 5. A sign that Antarctica still has stories to tell. If this entire script has a subtext, it's this. Antarctica is not empty. It's just quiet. And in that silence, the continent has kept secrets, geological secrets, biological secrets, atmospheric secrets, cosmic secrets. Anita didn't reveal those secrets, but it did something just as valuable. It reminded us that they exist. There are mountains under the ice we haven't mapped, lakes we've never sampled, caverns we've never entered, voids we've only glimpsed in radar echoes, particle paths we've never observed. A continent this vast, hidden, and ancient will not yield everything quickly. It reveals itself in pieces, glacially, appropriately. Anita's upward-moving pulses are just one piece, a small one. But in science, small pieces often belong to very big puzzles. 6. The future will answer what the present cannot. Eventually, IceCube Gen 2 will collect more data. PUEO and Beacon will fly. New Antarctic detectors will rise. New theoretical frameworks will refine predictions. And a future team, maybe 10 years from now, maybe 20, will look back at Anita's anomaly and say, of course, it was obvious once we had the right tools. That's how mysteries end, not with a twist, not with a revelation, not with fanfare. They end quietly, logically, elegantly, like puzzle pieces finally clicking together in the right shape. Anita lit the first pixel of a picture we haven't fully rendered yet. The rest will come. Take a moment, wherever you are, whether you're tucked under a blanket, drifting off in your room, or listening with one eye open at 3 in the morning, to think about how strange and wonderful it is that a mystery this big began with something so small. A blip, a pulse, a whisper rising from beneath the coldest place on earth. No fanfare, no drama, just a gentle nudge from the universe reminding us that discovery rarely arrives loudly. It arrives like this, quiet, stubborn, and patient. Antarctica is good at that. It doesn't reveal itself easily. It waits. It keeps secrets frozen in place for millions of years. It lets us see only the things we're ready to understand, and even then, only in pieces. For centuries, people filled its silence with stories, hidden worlds, lost civilizations, secret caverns, strange shadows, forgotten maps, and whether or not any of those myths have truth behind them, they all share the same instinct. We sense that Antarctica holds more than meets the eye. Then Anita arrived, a balloon drifting above an empty horizon, and captured something that didn't match any textbook, a radio pulse traveling the wrong way, a signal that shouldn't exist, a clue that something, some particle, some process, some cosmic fragment passed upward through the earth in a way we can't yet explain. Not supernatural, not fantastical, just unknown. And unknown is enough. It's enough to send researchers back to their models, enough to spark new experiments, enough to unite theorists who normally argue about equations only they understand, enough to remind us that even now, in a world full of data and satellites and sensors, there are still corners of reality we haven't mapped. You lived through one of those corners tonight, and the beauty of this mystery, this gentle anomaly from beneath the ice, is that you don't have to solve it. You can let it sit, let it breathe, let it settle into that part of your mind that holds wonder without needing answers, because answers will come eventually from new detectors, new missions, new generations of scientists who haven't been born yet. Someone will look back at Anita's anomaly one day and say, "Oh, that was just the first sign." But for now, we're allowed to enjoy the mystery for what it is, a reminder that the universe is bigger, older, and stranger than our comfort zones suggest, a reminder that even in the quietest places, in the stillness of Antarctica, in the darkness beneath the ice, in the thin air where a balloon drifts through silence, the universe is speaking, softly but speaking, and you are here to listen. So as you settle deeper into your pillow, or let your thoughts drift like the balloon over the ice, remember that you're part of a world that still has room for wonder, a world where mysteries are not threats but companions, gentle reminders that we're still exploring, still learning, still waking up to the vastness of everything around us. Thank you for spending this time with me tonight. Rest well. And whenever you're ready, we'll explore another mystery, quietly, patiently, and together. Good night.